a problem from vector algebra, and the problem is if a vector alpha is resolved into components parallel and perpendicular to the another vector beta, then show that the components are given two vector. This is the parallel component and this is the perpendicular component of beta. Okay, here to solve this problem we use three simple property of vector algebra. The first one is, we know that if two vector a and b are parallel, then any one of them can be expressed as the scalar component or scalar product of another. Okay, so we write b, this is equal to x into a. Here x is a scalar. Second one is, if a and b are perpendicular, then the scalar product or dot product is 0. Okay, and the third property, this is the expression of vector triple product of three vector. This is a cross b cross c, which is given by a dot c, a and c, which vector is further than the a, we write first in the dot product, and b in the outside of this dot product, minus a dot b, and here outside is c. We use these three result for solving this problem. Okay, now first write the vector alpha into two components. Let the first component is beta 1 and second component is beta 2, right, where beta 1 is parallel to beta and beta 2 is perpendicular to beta. Okay, and since beta 1 is parallel to beta, so we can write beta 1, this is equal to x into beta. We use the first property. Now we first put here beta 1, this is equal to x into beta. Then we get alpha, this is equal to x into beta plus beta 2. Now we taking dot product with beta, then we get beta dot alpha, this is beta dot x beta, this is vector, plus beta dot beta 2. Okay, and here beta dot beta 2, this is equal to 0 because beta 2 and beta is perpendicular, so beta 2 dot beta, this is equal to 0. Okay, this is the property, this second property. So we put here this is 0 and getting the result as beta dot, this is alpha, beta dot alpha, this is equal to x into beta dot beta. Okay, and this is 0. So we get beta dot alpha by mod beta whole square, because beta dot beta, this is equal to mod beta whole square. This is given by x. Now we putting the value of x. Here we get one component. This is beta 1. This is given by beta dot alpha by mod beta whole square beta. Okay, this is the first component, or this is the parallel component of beta, and this is our first result. Now clearly if we put the value of beta 1 here, then we clearly get from here beta 2, this is equal to alpha minus beta 1, right, and alpha minus, here we put the value of beta 1 which is given by beta dot alpha by mod beta square beta, right. Now taking LCM, we write this is alpha into mod beta whole square minus beta dot alpha into beta by mod beta whole square, and we may write this is equal to alpha, we write first mod beta whole square, this is beta dot beta alpha here, okay, minus this is beta dot alpha beta here by mod beta whole square. Now clearly we get the vector in the numerator is this type. Okay, and this vector can be written here a dot cb minus a dot b into c, which is given by a cross b cross c. So we write the above result as beta cross alpha by mod beta whole square. Okay, we use this result directly as a formula here. Okay, so we get beta 2, we write here beta 2, this is equal to beta cross alpha by mod beta whole square. Okay, so we get two component here, the second component, this is the second component which is perpendicular to beta, and here the first component we already get here the first component which is parallel to beta. So this is our second answer and this is the first one. Very simple but interesting and important problem of vector algebra. Thank you for watching.